Hello everyone, myself Arbahita, Assistant Professor of Rohini College of Engineering and Technology. I'm here to discuss a few topics in the subject CS 8592 Object Oriented Analysis and Design. In this, we are going to describe about the topic applying GoF design, that is Gang of Four design and creational patterns. Objective is to learn about the concepts of applying the Gang of Four design and creational patterns. First, let us know about applying the GoF design patterns. In 1994, four authors Erich Gamma, Richard Helm, Ralph Johnson, and John Blissitz published a book titled Design Patterns, Elements of Reusable Object-Oriented Software, which initiated the concept of the design pattern in software development. So all these four, that is Gang of Four. So they are called as Gang of Four: Erich Gamma, Richard Helm, Ralph Johnson, and John Blissitz. So all these four together published a book called Design Patterns. Okay, so this is called as Gang of Four design patterns. So these authors collectively known as Gang of Four, they found some principles of object oriented design, programmed to an interface, not an implementation, and favor the object composition over inheritance. Pattern and description. There are 23 design patterns which can be classified mainly into three categories, that is creational patterns, structural patterns, and behavioral patterns. First, about creational patterns. These design patterns provide a way to create the objects while hiding the creation logic, rather than instantiating the objects directly using new operator. This gives the program more flexibility in deciding which objects need to be created for a given use case. About structural patterns, these design patterns concern the class and object composition. Concept of inheritance is used to compose the interfaces and define ways to compose the objects to obtain the new functionalities. About behavioral patterns, these design patterns are specifically concerned with communication between the objects. The 23 design patterns are listed in this as creational, structural, behavior. So all these things are 23 design patterns. First, let us see about creational patterns. This makes the system independent of how the objects are created, composed, and represented. Abstract the instantiation process, which is hide how instances of these classes are created and assembled. Hide the references to create the class used in the system. Govern what, when, who, how object is created. And about abstract factory, which creates an instance of several families of classes, provides an interface for creating the families of related or dependent objects without specifying their concrete classes. About builder, which separates the object's construction from its representation. It separates the construction of a complex object from its representation so that the same construction process can create different representations. About factory method, which creates an instance of several derived classes and define an interface for creating an object, but let the subclasses decide which class to instantiate. Factory method lets a class defer instantiation to subclasses. About prototype, a fully initialized instance to be copied or cloned. So specify the kinds of objects to create using a prototypical instance and create a new object by copying this prototype. Singleton, a class of which only a single instance can exist. Ensure a class only which has an instance and provide a global point of access to it. Now let us see about mapping the design to the code. So implementation of object-oriented language requires writing the source code for the class and interface definitions and method definitions. So implementation can be discussed in Java. So for that, first we are going to create class definitions from the design class diagrams, that is DCD. Creating methods from the interaction diagrams, collection class in the code, exceptions and error handling, order of implementation, test driven or test first development. So first let us see about creating class definition from DCDs. The DCDs depict the class or interface name, superclasses, operation signatures and attributes of a class. So if the design class diagram was drawn in a UML tool, it can generate the base class definition from the diagrams. So defining a class with the method, signatures and attributes from the DCD, a mapping to the attribute definition, that is Java fields and method signatures for the Java definition of sales item is straightforward. This is a diagram which shows the mapping of these codes. Creating methods from interaction diagrams. The sequence of the methods or messages in an interaction diagram translates to a series of statements in the method definition. The inter-item interaction diagram illustrates the Java definition of the inter-item method. For example, we'll explore the implementation of the register and the inter-item method. A Java definition for the register class is shown in the diagram below. Now let us see about test-driven or test-first development. An excellent practice promoted by the iterative and agile XP method and the applicable to the UP, that is unified process, is a test-driven development. In the OO unit testing TDD style, test code is written before the class to be tested and the developer writes the unit testing code for nearly all production code. The basic rhythm is to write a little test code, write a little production code, make it pass the test, write some more test code and so forth. Example, suppose if we create a TDD for the sale class, before programming the sale class we have to write a unit testing method in a sales test class that does the following. Each testing method follows this pattern to create the fixture, do something to it and evaluate that the results are as expected. So these are the codings which we retrieve from the classes, and this is for class register. Similarly, we will make so many classes and the codes will be generated accordingly. That is the mapping design to the code. Thank you.